Hello, everyone. Welcome back for this for the third session of the maths program of the Study Ready sessions. So today we're gonna talk about lines and how to solve equations. So we're gonna see how we can plot straight lines, how we can use the equation of a straight line, and how to solve linear equations algebraically. Let me go to the introduction. So here is a small outline of the session. So we're gonna start with straight lines, and then we're gonna move on to the solution of linear equations. At the end of the session, I will recommend some resources that you might want to use for further practice. So let's start. Now, by intuition, we know that if we want to plot, if we want to graph a straight line, we just need to know 2 points. So in order to plot a straight line, we just need 2 points. For example, let's say we want to plot the line that passes through the points A, 1, 2, and B, 3, 4. So how we can plot this line? First, we can draw the axis. So let me draw. So here we have the x-axis, and this is the y-axis. Let's find the point A. So point A is for x equals 1. So let's say this is 1, and y is equal to 2. So 1, 2, let's say it's here. So this is our point A, 1, 2. And then point B has x coordinate 3, so 2, 3, and y coordinate 4. So let's say it's over here. So this is B with y coordinate 4. So now we have those 2 points, and we can join the points, and then we extend this line. So this is the line that passes through the point A, 1, 2, and B, 3, 4. Okay, this is pretty simple. Another example, for example, let's say we want to draw the line that passes through the points A, minus 3, minus 1, 3, and B, 0, 2. Again, the first step is we draw the 2 axes, the x-axis and the y-axis. Let's find point A. So point A is minus 1. So the x-coordinate is minus 1. So this is x-coordinate. This is y-coordinate. So we go here, minus 1. This is 0. This is 1. And for the y-coordinate, we want 3. So 1, 2, 3. So this is our point A, minus 1, 3. And B has has x-coordinate 0. So it's on the y-axis, and the y coordinate is 2. So if this is 1, here is 2. Okay, so this is B, 0, 2. Again, we can join these 2 points, and then we extend this line. So this is the line which passes through point A and B. So always, if we want to plot a straight line, we just need to know 2 points. Now let's try to be a little bit more systematic, and let's introduce the equation of a straight line. So the equation of a straight line is given by this formula. So this is y equals to mx plus some constant c. So a point on a line has coordinate x and coordinate y. And if the point belongs to this line, then the coordinates of the point satisfy the equation of the straight line. M, the constant m, is the gradient or the slope of the line, and it measures the steepness of the line. The larger the value of m, the steeper is the line. We can calculate the gradient of a line if we just know 2 points. So if we know 2 points, A with coordinates x, a, and y, a, and point B with coordinate x, b, y, b, then the gradient is given by this formula. So change in y over change in x. So y b minus y a on the numerator over x b minus xa, the denominator. So we can use this formula to calculate the gradient of a line whenever we know 2 points. The constant c is called the intercept, and it gives the y coordinate of the point where the line crosses the y axis. Let's do some examples to see how we can identify the gradient and the intercept of some lines. So for example, in the first case, we have an equation of the line which reads as y equals 2x plus 5. So in this case, the gradient is equal to 2 and the intercept c is equal to 5. Second example, y equals minus x plus 5 over 2. So in this case, the slope is minus 1 and the intercept is 5 over 2. Sometimes we're given the equation of a straight line, as in example 3, where we need to rearrange it to make it in the standard form. Okay, so here we have y minus 3x plus 11. We can add 3x both sides, and we can rearrange the equation to write it as 3x plus 11. Okay, so this is equivalent. So in this case, the gradient is 3 and the intercept is 11. Notice that in the second example, the slope is minus 1. Okay, so the minus, we take it for the gradient. Okay, so it's minus 1. Okay, be careful with the signs. Let's try and plot the following lines given the equation of the line. Okay, so let's take the first example. Let's draw our axis. Okay, so we're gonna, so let me draw here. Okay, so this is x, this is y. Let's plot first the line y equals x. This is a line that passes through the origin. Okay, so this is the origin with coordinates 0, 0. Remember, if we want to plot a straight line, we just need 2 points. So if I take the point with coordinate x equal 1, then for this line, y is equal to 1. If I take x equals to minus 1, then y is equal to minus 1. So 1, minus 1, 1, minus 1. So I just need to connect these 2 points. So this is the line y equals x. It's a line that passes through, the origin. For the second one, we have y equals 2x. Again, if we take x equals 0, y is 0. So this line, y equals 2x, again passes through the origin. We take x equals 1, y now is 2. So it would be here. So 2 points that belong to the line y equals 2x is the origin and the point 1, 2. So let's join these 2 points. So this is y equals 2x. Let's extend here. So you see now that the gradient here is 2, whereas here the gradient is 1. So as we increase the gradient, the line gets steeper. And let's draw the third line, 2x plus, what was it? Plus 5. Again, we need 2 points. The easy one is always to take x equals to 0. Then we see that y should be 2 times 0 plus 5. So y should be 5. So 1 point that belongs to the line 2x plus 5 is the 0, 5. So 3, 4, 5. So it's this point. So our line will pass through this point. We want to find another point. Let's take x equals to 1. Then y is 2 times 1 plus 5. So y is equal to 7. Let me extend a bit this the y-axis. So this is the y-axis, so 6, 7, 1, 7. So this is the point 1, 7. And the line y to x plus 5 is this one. It's parallel to the line to y equals to x. Again, so given the equation of a straight line, we can use it to find 2 points, and then we can draw the line. Okay? So now let's see how we can use the formula for the slope to calculate, to find the slope of a line that we know that passes through 2 points. So in this example, we want to determine the gradient of the line which passes through the points a 1, 2 and b 3, 4. Remember, the formula for this case is change in y over change in x. So in this case, we just need to substitute the coordinates of the points to calculate the gradient. Let's do the numerator. So yb, this is 4, minus ya, so minus 2, xb, so this is 3, minus xa, this is 1, and then it's just a matter of calculation, so 2 over 2, so this is equal to 1. So the gradient in this case is equal to 1. Okay, so we just substitute the coordinates of the points. Let's do another example. Determine the gradient of the line which passes through the points a minus 1, 3, b 0, 2. Okay. Be careful with the signs. So yb is 2 minus ya, this is 3, xb, this is 0, minus, and the x coordinate of a is minus 1. I'll put it in brackets. So 2 minus 3, this is minus 1. 0 minus the minus 1, so we have 2 minus, it will be a plus, so we're just gonna get 1. So we have 1 minus 1 over 1, this is minus 1. So in this case, the gradient is minus 1. Later, after we go through the session, through the part of solving linear equations, we're gonna see that how we can find the equation of a straight line given 2 points. Okay, first we find the gradient or the slope of the line, and then we will see how we can use one of the points to find the slope. Okay. Let me recap here. So in general, the equation of a straight line, so equation of a straight line is given by y equals mx plus c. M is the slope of the line or the gradient. C is the intercept. Is the y coordinate of the point where the line crosses the y-axis. Now, if we know 2 points of the line, A and B, we can always find the gradient, which is given by the change in y over the change in B. Given 2 points, we can always draw the line. If we are given the equation of a line, we can always find 2 points that belong to the line. We just choose values for the x coordinate, find the y coordinate, and get 2 points to plot the line. Okay, now let's move on the part of solving linear equations. Some terminology first. So an equation is a mathematical expression stating that two parts or sides are equal. So an equation is a mathematical expression stating that two parts or sides are equal. Usually, always an equation contains an unknown, which we usually denote by x. And the unknown is what we wish to find. Now, a linear equation is an equation that only involves numbers and terms such as a times x, where a is called the coefficient of x. A linear equation does not contain terms such as x to the square, x to the cube, square root of x. Okay. For example, this is a linear equation. We only have constants and terms of the form ax. This is another one. We have only constants, 5 times 3, 5x, and terms 5x equals 2x. So we only have, again, constants and terms of the form ax. Similar here, this is a coefficient for x, 4 over 9. 2 is a constant. 3 times 2x would be 6x, plus 3 times 8 would be another constant. So this is also linear. This one is not linear. We see that we have a power of 2 for the unknown. This is a quadratic equation. Okay, so not a linear equation. This is a quadratic equation. In this session, we are interested in solving linear equations, so equations of this form. Okay. And the main method is the method of collecting same terms or keeping the balance. So for example, if we want to solve the following equation 2x plus 7 equals 14. For this equation, or in general, for an equation, the equality sign represents a balance between the left-hand side and the right-hand side. Our goal is to isolate the unknown in one side and the numbers to the other side in order to obtain the solution in the following form. So we want to write down that x equals something. This would be our solution. To find the unknown, we add, subtract, multiply, or divide by appropriate terms and numbers the equation. So the main thing that we should remember is that always, whatever you do in one side of the equation, you need to do the same to the other side so that you keep the balance. Okay, so let's solve this equation. 2x plus 7 equals 14. Okay, so we want to isolate x. In order to do this, let's first isolate 2x. So we have 2x plus 7 equals 14. We want to get rid of this 7. What we can do is we can subtract 7 from both sides. So 2x plus 7 minus 7 equals 14 minus 7. Okay, so 7 minus 7 will be 0. So on the left-hand side, I would only have 2x. The right-hand side would be 14 minus 7, so this is 7. And now I want to have only x on the left-hand side. We have this constant 2, so 2 times x equals 7. If I divide both sides with a 2, we can cancel the 2 on the left-hand side. So 2x over 2 equals 7 over 2. So here we see that 2 and 2 cancel. So x equals 7 over 2. And this is the solution. You see that from the equation, we go to an expression that says x equals something. In this case, 7 over 2. And this is the main idea always. So we want to isolate the unknown and we keep the constants, all the known constants to the other side. There is a very nice online illustration of this method on Maths is Fun. Let me go here, for example, to see an example. Balance when adding and subtracting. So here we have this scale. We are given an equation and we want to solve the equation by adding or subtracting 1, adding or subtracting the unknown. And we do, whenever we add or subtract, we do the same to both sides of the equation. So we keep the balance. So we have minus 3x minus 3 equals minus 4x plus 3. If we want to get rid of the minus 3, we can add 1 to both sides. One more time. Okay. So now we have minus 3x equals minus 4x plus 6. Let's start adding x to both sides. So 1, 2, 3. So here we now have 0 equals minus x plus 6. So if I add x to both sides, I will get my answer. So I will add x, so x equals 6. Whatever we do in one side, we can do to the other. We always do to the other side too. New equation, you can try yourself. Let's go back. Let's see more examples and other types of linear equations or other forms of linear equations and see how we can solve them. So for example, you might end up with a linear equation that contains brackets. So for example, 5 plus 3, open bracket x minus 1, close the bracket, equals 5x minus 6. Again, we're trying to isolate the unknown and to end up with an expression x equals something. If we have brackets, first we expand the brackets. So starting with the equation, we have 5 plus. So 3 hits x, and then minus 1 plus 3x, 3 times minus 1 minus 3 equals 5x minus 6. Let's collect the unknowns. So 3x, 5 minus 3, this would be 2. 5x minus 6. Now let's try and move this 6. So if I add 6 to both sides, 3x plus 2 plus 6 equals 5x minus 6 plus 6. So here we're going to get 0. So we have 3x. 2 plus 6, this is 8, equals 5x. Let's isolate x and move all x, all the unknowns to the right-hand side. So I'm going to subtract 3x from both sides. So 5x minus 3x. 3x minus 3x would be 0. So I'm only left with 8. 5x minus 3, this is 2x. So now if I want to find x, I divide both sides with a 2. 2 multiplies x, so I do the opposite. So x now is equal to 4. And this is your solution. So if you have brackets, first we expand the brackets, and then we collect the same terms. We solve the linear equation as we did in the previous case. We may have brackets on both sides. Again, we expand the brackets. So 4 with x, 4 with 3. So 4x plus 4 times 3, this is 12. Equals 4 times 2, 2 times x, this is 2x, 2 times 1, this is 2. Let's collect the constants first. We're gonna collect to the right-hand side. So 4x plus 12 minus 12 equals 2x plus 2 minus 12. This is 0. 4x equals 2x. 2 minus 12, this is minus 10. And then we subtract 2x from both sides, so we have 0x on the right-hand side. So 4x minus 2x, 2x minus 10 minus 2x. So this and this cancel. 2x, 4x minus 2x will give us 2x equals minus 10. We have a 2. We divide with a 2 both sides. We can simplify the 2 here. So x is minus, we keep, so have minus 10 divided by 2. minus 5. So here we had brackets both sides of the equation, so we had to expand the brackets both sides of the equation. Yeah, this looks a little bit more complicated, but again, the approach is the same. Expand all brackets, collect the unknowns to the left-hand side, the constants to the right-hand side, and then find the solution. So let's start expanding the bracket. So 8 times x, 8 times minus 3. So 8 times x, 8 times 3, 24. We have a minus, we keep the minus. So here we have minus or minus. Here we have minus 1. Okay, so minus 1 times 6 will give us 6 minus minus will give us a plus. So 2x equals 2x plus 4 minus 5 times 5. This is minus 25. Minus 5 times minus 6, 2 minus. So minus minus will be plus 5x. Okay, let's collect 8x plus 2x. So this is 10x. Minus 24 minus 6. This should be minus 30. Then we have 2x plus 5x. This is 7x. And then we have 4 minus 25. This is minus 21. Okay, let's try to get rid of the minus 30. So I'll add 30 to both sides. Whatever I do in one side, I do to the other side too. So plus 30. This is 0. 10x equals 7x. So minus 21 plus 30. This is 30 minus 21. Okay, so this is plus 9. And then I want to get rid of the 7x here. I want to have the unknown on the left-hand side. So I subtract 7. From both sides. The left-hand side will be 3x. The right-hand side, this and this cancel, will give me 9. And now I have 3x equals 9. What should x be? I divide with a 3 both sides. 3, 3. Simplify. X equals 3. This is your solution. Okay, so even though that we had many brackets, we had to expand the brackets, collect the same terms, isolate the unknown. This is always the approach. Okay, let's see also a third case. So solving linear equations when you have fractional coefficients. So equations of this form, so 5 plus x over 3 equals 7. How we can do this? Again, try to isolate the unknown. Try to keep the unknown only on one side. So here, if I subtract 5 first from both sides, I'll get 7 minus 5. 5 here cancel. X over 3 is equal to 2. 7 minus 5 is equal to 2. Now here I have x over 3. So 3 divides x. If I want to get rid of the 3, I do the opposite. So if I multiply both sides with 3, I get 3 times 2. 3x over 3, so this is like 3x over 3. So you can simplify, you get the 6. So x equals 6. So if you have fractional coefficient, you usually need to multiply. Let's do this example. This looks a little bit more complicated. So we have x plus 2 divided by 3 equals 1 minus 2x divided by 5. In this case, we first need to get rid of the denominators. So notice that x plus 2 is one thing on the numerator, 1 minus 2x is one thing on this numerator, on the numerator here. So first, if I multiply with a 3, both sides, on the left-hand side, I can simplify the 3. Okay, so this is 3x minus x plus 2 over 3. This is 3, 1 minus 2x over 5. 3, 3, we can cancel. So we end up with x plus 2 equals 3, 1 minus 2x over 5. If we want to get rid of the 5, because 5 divides this 3 bracket 1 minus 2x, we can again multiply with a 5. But if we multiply with a 5, we multiply both sides with a 5. So 5x plus 2 equals 5, 3, 1 minus 2x over 5. Okay, so we have 5x plus 2 equals, this is 5 times 3 times 1 minus 2x over 5. 5, 5, we can simplify. So we have 5x plus 2 equals 3, 1 minus 2x. So we go back to the case that we have a linear equation and we also have brackets. How we solve this? We expand now the brackets and then we collect same terms. So 5 times x, 5x. 5 times 2, 10 equals 3 times 1, 3. 3 times minus 2x, we get a minus. 3 times 2, this is 6x. So 3 minus 6x. And now we collect same terms. What we can do, we can, let's get rid of the 10. So 5x plus 10, it's a plus, so we subtract 10 from this side, and we do the same to the left, to the right-hand side, so minus 10. Here these two cancel, so 5x equals 3 minus 10, this is minus 7. Minus 6. We want to get rid of the minus 6, so we add 6 to both sides. Minus 7, minus 6. These now cancel. 11x equals minus 7. And now we want to write down x equals something. So we want to get rid of the 11 because 11 multiplies the unknown. We divide both sides with 11. 11 and 11 we can simplify. So x is equal to minus. The minus can go in front of the fraction. This is the solution. So starting with an equation of this form where you have fractional coefficients now, we can get rid of the denominators first by multiplying. First with a 3, then with a 5. You could multiply with 15 and get rid of the denominators just in one step. So you end up with an equation here. So this is a linear equation given in brackets. We have also brackets, so we expand the brackets and then we rearrange to solve for the unknown. Okay, so now we have seen how we can solve linear equations. Let's do a couple of problems using a technique to solve linear equations. So as I said in the beginning, now let's see how we can find the equation of a straight line given 2 points. And for this, we're going to need to solve an equation, a simple linear equation. So find the equation of the straight line passing through the points A minus 1, 2, B 1, minus 3. So the general equation of a straight line is always like this: y equals mx plus c. M is the slope, the gradient. We can find it by taking the change in y over the change in x. So here y, so what are the points? The points are a is minus 1 comma 2, b is 1 comma minus 3. So what is the coordinate, the y coordinate of point b? This is minus 3 minus 1. The coordinate of, no, minus 2. The y coordinate of a. This is the second coordinate. xb, this is 1 minus the minus 1. So minus 3 minus 2, this is minus 5. 1 minus the minus 1 is plus 1. So minus 5 over 2 minus 5 over 2. So this is the gradient. So we have found these numbers, the gradient, the m. What is c? How we can find the intercept, c? So now the equation of the line is of this form, minus 5 over 2x plus this constant c. We can use any of the 2 points that belong to the line to find c. How we can do this? So let's take the point a. So a minus 1 comma 2 belongs to the line. So this means that it satisfies the equation of the straight line. So whenever x is minus 1, y is equal to 2. Let's substitute back to the equation of the straight line. So 2 equals minus 5 over 2 times minus 1 plus the constant c. So here now we have a linear equation where the unknown is the intercept. And we just need to solve for the unknown. We have 2 equals minus 5 over 2 times minus 1. So this is just 5 over 2 minus minus will be plus c. So we want to isolate the unknown, the c. So I can subtract 5 over 2 from both sides, and I will get 2 minus 5 over 2 equals to c. In other words, c is 4 minus 5 over 2 minus 1 over 2. So this is c, and the equation of the straight line now is minus 5 over 2 x minus 1 over 2. So this is how we can find the equation of a straight line given 2 points. Okay, we can find first the slope, which was minus 1, and then we can choose any of the points, substitute back the equation, and solve for the intercept, which is now the unknown. It's the only unknown that remains to find. Now let's see how we can also like use an equation, how we can write down an equation to solve a problem. So here for this problem, we want to find the sum of 3 consecutive numbers, which is the sum is equal to 63. So we want to find these 2 numbers. So let's say, so 3 consecutive numbers, we can denote them as x. The next one is x plus 1, and the third one would be x plus 2. Okay, so these are 3 consecutive numbers. What we know that x plus 1 plus x plus 2 equals 63. So if I can find x, then I have found these 3 numbers. So now we have translated the hypothesis into an equation, a linear equation. How we solve a linear equation? We collect same terms. X plus 1 plus x plus 2 equals 63. How many x do I have? 1, 2, 3. 1 plus 2, so 3 equals 63. I want to get rid of this 3. Okay, remember we want to write down x equals something, so 3x plus 3 minus 3. I want to get rid of the 3 to isolate the unknown. So I have 3x equals 60. 3x equals 60, so I want to get rid of this 3 now, so 3 multiplies the unknown, so I divide with a 3 both sides. Here we can simplify 3, so x equals 60 over 3, which is 20. So 3 consecutive numbers that add up to 63 would be 20, 21, 22. So this was the last example, the last problem for this session, how we can use an equation to solve a simple problem. There are more complicated problems that, again, you can write down a linear equation to find your solution. Now, if you like to practice more, here you can find worksheets from the Math Center, interactive tools from Math is Fun, and more examples. How you can find these notes. So if you go to the Study Ready guide, the homepage of the Study Ready guide, and scroll down here, you will see the session for the section for the math program. And here are the notes with all the links to use. So if you go to the last page, you can see here all the links. Okay. Worksheets, interactive tools, and just to mention, if you want to find out more about the Maths and Stats team on Skills for Success, you can visit the homepage of the Maths and Stats. So this is the link here. You can find it in the notes too. Thank you very much for watching the recording. And now I'm gonna stop sharing and I'm gonna stop the recording too. So let me see how I can do this.